All right, this is Math 2, Unit 9.5, Volume of Pyramids and Cones. This is always one of my favorite lessons to teach because you might have seen those clear plastic three-dimensional objects I have in my room up there by the front. I have a rectangular plastic prism, okay, and it looks like this, sorta. And I also have a plastic rectangular pyramid. And let's see here if I can get this semi-done right. And, oh, that's not very good, but you get the idea. Well, the prism and the pyramid have the same dimensions, okay? And what I do is I always get one of my talkative students to come up, and I get some water, and I pour the water into the pyramid to the very top, and then I have them dump it in. And I do that 3 times, and what we find out is 3 of these equal 1 of those. Even though they have the same dimensions, the volume of 3 pyramids equals the volume of 1 prism with the same dimensions. And I always keep pouring when they tell me to stop and make a big mess and pour water all over them, and it's always kind of funny. I'm sad we don't get to do that this year. But that big demonstration leads up to explain that to find the volume of the pyramid, we use the same formula we use to find the volume of a rectangular prism. The volume of a rectangular prism is big B times H. And the only difference is, since it takes 3 pyramids to fill up 1 prism, we have to take this formula and we have to divide it by 3. So to find the volume of any pyramid or cone, we take the volume of a rectangular prism formula or the volume of a cone, and we simply multiply it by 1/3, because it takes 3 pyramids to fill up 1 prism with the same dimensions. Okay, so that's how we came up with the formula. Now, in a prism, in a pyramid, we have couple of things that we do differently. We call this the base edge. Call that the base edge. And from the top of the pyramid straight down, as if it was holding a string, to the very center of the base is where we get our height. Okay? And from the very center of the pyramid out to the edge is half of our base edge. This is half of our base edge. And then you'll see this right here. This is what we call the slant height. The slant height. And you do not want to get that mixed up with the actual height of the pyramid, although students do it every year. And what you might notice is the height of the pyramid, the half the base of the pyramid, and the slant height create a perfect right triangle. So we use Pythagorean theorem a lot here to find the height or the half the base edge, or sometimes even the slant height if you're asked to get that. Okay, so let's go ahead and jump in here and see what we got here for question number 1. So the right square based pyramid with height 8, so let's put that in as 8, okay, and a slant height of 17, find the volume. All right, so already we're going to have to use Pythagorean theorem to find this half of the base edge. So we're going to call this, let's just call it A, okay? And we're going to say A squared plus B squared equals C squared, or A squared plus 17 squared, plus 8 squared, 8 equals 17 squared, okay? Which means A squared plus 64 equals 289. Double check myself here. I know that's right, but don't want to mess up here. Of course, I got to trust myself. All right, so if we subtract 64 from both sides, we get A squared equals 225. We take the square root of both sides, and we find out that A equals 15. Okay, so we know A is 15, which means our base edge is actually 30. Okay, remember that this is half of the base edge. All right, now to find the volume. Let's go way over here to do volume. Okay, so remember volume is 1/3 the base area. Now let's think about what the base area is. Remember, we said it's a square and it will always be a square. Okay, everything we're going to cover here, this unit is a square. So the base area must be 30 times 30, right? Length times width. 30 times 30, which is 900, times the height, which is 8. Okay, the nice thing is 1/3 of 900, or 900 times 1/3 is 300 times 8, which is simply 2400. And this is, well, we don't have any measurements, so we'll just call it units cubed. All right, so we had to use the height and the slant height to find this length right here, which is half of the base edge. So this was 15, so the base edge was 30. To find the area of the base, we multiplied 30 times 30 because we knew it was a square. 30 times 30 is 900. We plug that into our formula. Volume equals 1/3 the base area times the height. We knew the height was 8 already. Multiplied and got 2400 units cubed. All right, let's see. A right-based pyramid with a base edge of 6 and a height of 4. Find the volume. That one's pretty straightforward. I'm going to leave that for you guys. Number 3, find the square-based pyramid with a base edge of 16 and a slant height of 10. Find the volume. Okay, so the base area we know, let's do that. Base area equals 16 times 16, right? That'll give us the base area. So remember, volume equals base area, 1/3 base area times the height. So volume equals 1/3. Okay, 16 times 16 is what, 256? All we need is the height now. Problem is, we don't have the height. It's right here. But can we find it using this triangle that we used last time? Well, we always need 2 of the 3 pieces to use Pythagorean theorem. Luckily, we know that this is half the base, so it must be 8. So if I draw this little triangle here, we know the slant height is 10, okay, which is the hypotenuse, and the base edge here, half the base edge is 8. We just need the height. Now some of you are going to go h squared plus 8 squared equals 10 squared and solve for h, but some of you might remember a 3, 4, 5 right triangle. 2 times 3, 2 times 4, 2 times 5. So we know the height is actually 6. Okay, so we can get our calculator out here fine, right quick. But we know 1/3 of 6 is 2, and 2 times 256 is 512. So our volume is 512 units cubed. Okay. So finding the volume of a cone is the same as a pyramid, except our base has changed from a square to a circle. So we find the area of the circle and multiply it times the height, and then divide it by 3, or multiply by 1/3. So let's see what we know here for number 7. Let's see, we know the radius is 9. We know the height is 12. This one's pretty straightforward. Find the volume. Volume equals base area times height. Volume equals, well, the base area is pi times radius squared, and the height is 12. So volume equals 81 pi times a height of 12. And let's do that. Let's go 81 times 12, and we get 972. So this guy has a volume of 972 pi units cubed. All right. A right cone has a diameter of 12, which means our radius is 6, and a height of 6 root 3. Okay, so this is obviously a 30, 60, 90 right triangle. Does that matter? I don't think so. In this case, they want the volume. So the volume equals pi r squared times the height. I'm going to leave these next two for you. This one is a work backwards problem. So let's see. I think you guys can do this one. We want to find the height. The radius is 15 and the volume is 600. This is the volume, 600 pi. So volume equals pi times radius squared times height. Plug in the volume. Plug in the radius. Work backwards to find h. Okay, number 10. It looks like we got the problem here and the cone on the other side. Let's see, a right cone with a volume of 43 pi. Alright, I'll help you out with number 10. Alright, so V equals base area, or pi r squared, times the height. What do we know? We know the volume is 432 pi. And we have pi times, looks like we're looking for the radius, and times 9. Alright. Remember, when we are dealing with work backwards problem with circles, cross out those pi's. So 432 equals 9r squared. Let's divide both sides by 9. And we get 432 divided by 9. We get 48. And we divide this by pi, we get 1r squared, or just r squared. Take the square root of both sides. The square root of r squared is r. And the square root of 48 is, what is it here? We got 4 root 3, right? Boy, it's been a long time. Let me double check that real quick. Of course it is. 4 root 3. So our radius is 4 root 3. Okay. Okay, so we have 9 and we have 4 root 3 here for a radius. But what do they want us to find? Actually want us to find the slant height. So we're going to call slant height C. And we know that it's 9 squared plus 4 root 3 squared equals C squared. Or 81 equals, well, 4 squared is 16 and square root 3 squared is 3. So 3 times 16 is right back where we started. 48 equals C squared. Okay, and oops, that's a plus, sorry. So that is what, 129? Okay, so let's take the square root of 129. Let's see what we get. I don't think we're going to get anything. Nope. So we take the square root of both sides and we get C, which is the slant height, is the square root of 129. Alright, so whenever you come up with strange answers, I always like to go back and double check my work. I make mistakes all the time. So volume equals pi r squared times height. We were told the volume was 432 pi. We were looking for the radius because we already knew the height. Got rid of the pi's, divided both sides by 9. 9 divided by 9 is 1. We end up with r squared. 432 divided by 9 was 48. Okay. Took the square root of both sides and we got a radius of 4 root 3. Then 9 squared plus 4 root 3 squared equals C squared. So that's 81 plus 48. 81 plus 48 equals 129, square root. There we go. So the slant height is the square root of 129. Okay, we did one like that. I'm going to need number 11 for you guys to do. And number 12 I'll help you out with. Okay, so you got a Pringles are sold in a tall and short can. That's the short can, there's a tall can. The area of the base of each container is 16 pi. So we know they have the same base area. Okay, the volume of the short container is 128 pi. So we know the volume of the whole thing is 128 pi cubed, and the tall container is 6 inches taller. Okay? What is the volume of the tall can? So what usually happens here, I'll show you two ways to do this. So usually we find the height of the short can, and then we add 6 and we find the volume of the whole thing. So basically volume equals base area times height, and that's 128 pi. Luckily they give us the base area of 16 pi and the height, and we simply have to go 128 pi divided by 16 pi, and we get 8. I didn't bother with the pi's because we can simply cross them out. So we get a height of 8. Well, remember, this guy is 6 centimeters taller, so his height must be 8 plus 6, or 14. So to find his volume, it's simply volume equals base area, or 16 pi, times 14, which means it has a volume of 16 pi times 14, which is 224 pi. And of course this is, what is it, centimeters cubed. Alright, that's one way of doing it. Okay, now the other way of doing it is just realizing that this can has a volume of 128 pi, and this guy is 6 centimeters taller right there. But this much of it is 8. We didn't know that at the time. We really don't need to know it. We know that this much has a volume of 108 pi, and this guy is 6 bigger. So all we need to do is find the volume of 6 and add it to 128. So the volume of 6 is simply 16 pi times 6, and volume equals 16 times 6 is 96 pi. And if we add 96 pi to 128 pi, we end up with a volume of 224 pi centimeters cubed. So either find the volume of the additional 6 and add it to the volume of the smaller can, or work backwards, find the height of the smaller can, add 6 to it, and find the volume. Either are pretty simple. Okay, and that's 9.6. Or excuse me, is that 9.6 or 9.5? 9.5.